Welcome one and all to For Math Lovers. In this one we're going to take a look at demystifying the relationship between e to the x and ln x. So in other words, these are basically function inverses. Please remember that my channel is for those who are really interested in mathematics, like to explore it perhaps beyond just what it is that you learn in mere school. Let's take a look here. I'm going to begin with that graph. Some of it will seem perhaps familiar. It's a basic graph. Along the horizontal we have the x, along the vertical the y-axis. Let's make a picture. Now this graph represents e to the x. On this graph, let's take a look. On the horizontal, I put x sub 0. That's a particular value of x that you can feed in. You feed that in, it goes essentially, so to speak, through the graph, and it out comes on the y-axis. That's e to the x sub 0. That's the output. So when you grab values from the x-axis, you output them on the y-axis. That's the usual way of reading a graph. That's the conventional way mostly learned in school. But is that the only way of reading a graph? That's the fundamental question. And the answer, of course, is no. That is not the only way. Take a look at what I mean. So I can erase that, and instead, I'm going to grab a value from the y-axis. So notice that now the green arrow is basically approximately pointing to, let's see, about 3.5 maybe along the y-axis. The point is that it's grabbing a value from the y-axis. It's going through the curve, and the output will now be falling along the horizontal x-axis down below. So when you do it from that perspective, what originally was called e to the x is simply now called ln of y. I'm calling it ln of y because ln is short for log natural, or the natural logarithm function. And I'm using the y variable because we're taking inputs from the y-axis, feeding them into this function and putting them along the horizontal x-axis. So reversing the natural way of reading a graph, not the natural way, but the conventional way, so to speak. So from this perspective, when you take values from the y-axis and now put them along the horizontal, that's not e to the x anymore. Now it's the natural log function. It's ln. So in reality, the natural log and the ln function are inverses. Whatever the first one does, the natural log reverses. So whatever e to the x does, the natural log reverses, you see? Because it takes that value back from the y-axis to the x-axis. So that's y sub 0, and what it outputs along the horizontal is ln, for example, of y sub 0. In mathematics, when we write y sub 0, we just mean like a particular value of the variable. Maybe it could be 3.5, 3.7. We don't know what it is, so we can call it y sub 0. And then the output follows along the horizontal axis. You can call that, for example, ln of y sub 0. But the point, the essential concept is that from this perspective, this is the natural log function. Let's go back to the e to the x function. And here, remember on this one, you take values from the x, feed them to the function, output them on the y-axis. The output again is called e to the x sub 0. That's just a symbolic form of the output. For example, if x sub 0 were like 2, you would have e to the second. That's a number, that's all it is. That's just a number. Here, I'm going to take a look at these little lines that I'm drawing. I'm drawing them between the curve and the x-axis on the negative side. Let's observe something here. And I'm going to zoom in. We need to be able to zoom in to study this a little more closely. Take a look. You see that curve, that's e to the x. And I've drawn little double-ended arrows. They don't have to be double-ended. There's nothing special about that. But the point is that the curve, you see as x goes towards negative infinity, the way you see it here. X is traveling towards negative infinity, negative 1, negative 2, negative 3, negative 4, negative 5. You see that the graph collapses towards 0. But we say that the e to the x function is asymptotic towards 0, or in other words, it approaches the value 0 but never reaches it. So here you see these little double-ended arrows. They get shorter and shorter. They get forever shorter, but they never actually equal 0. The graph never actually crosses the x-axis or even touches the x-axis, so to speak. So that's one thing to be observed. And often what we do after that is take a look. We have a way of marking that. We call that a horizontal asymptote. So that's represented usually by a dashed line of some kind. So in this case, you see there's like a yellow dashed line, and that dashed line is the horizontal asymptote. It's a line you approach but you don't cross. So this is the view from e to the x. From the perspective of e to the x, the x-axis, which is also y equals 0, that's a horizontal asymptote. But now let's switch our views a little bit. What happens from the perspective of the natural log function? what happens to that asymptote. So to visualize this way properly, take a look. I want to make my version of the natural log function look like the one you might get when you graph it on a calculator, so the two can be reconciled. How do I go about that? Well, take a look. These are some possible steps. I begin with this, and I'm going to first rotate 90 degrees, and then after that, look carefully. I'm going to tilt it or swivel it that way until it stops. And now, when you graph the natural log function, this is what your calculator will show you. And perhaps you've learned before that the natural log function has a vertical asymptote at x equals 0. So along the y-axis, there's a vertical asymptote, a line that you approach but you cannot cross. Now think about it. This is exactly the same picture as for e to the x. It's just been rotated a little bit. So whatever was the horizontal asymptote for the e to the x function, for the natural log function from this perspective becomes the vertical asymptote. I haven't changed anything. It's exactly the same graph, the same arrows, the same asymptote, and so on. I wanted to kind of point that out, that when you transform from e to the x, the ln of y, what originally was the horizontal asymptote becomes the vertical asymptote on this one. And also further remember the following. I'm going to zoom in here, okay? Let me pull up. Remember these little arrows right here? Those are exactly the same ones as for e to the x. I haven't changed anything. For e to the x, those arrows indicate that e to the x gets closer and closer and closer to the x-axis. Here they indicate that the graph ln of y gets closer and closer to the y-axis. I hope you can truly see that and understand that. When I rotate the picture, obviously the numbers would have to be adjusted the way we write the numbers, but I think you can still make it out that this says 1, 2, 3, 4, 5 on the horizontal y-axis. On the vertical here it says 1, 2, 3. The only thing perhaps remaining to make this picture kind of reconcile better with the standard way is usually at this point the horizontal axis is renamed back to being x and the vertical is renamed y again. That's the conventional way of doing things, but the essential concepts are exactly contained in what I have demonstrated to you through these pictures. I hope this has been helpful. If it has, please leave a like. Thank you so much for watching. I'll see you in another video.